So in this video we're going to demonstrate multiplication using the Roman counting board and the Roman abacus, and we're going to use some of the techniques that we've been using in the Reading Ancient Schoolroom. This video presupposes the information in our video called Introduction to the Roman Abacus and Counting Board, so you might like to watch that video first. Now, to show how we do multiplication, I'm going to start with a simple sum. I'm going to start with 7 times 11. If you already know the answer, imagine that you don't, so that we can see how this would work on the counting board or the abacus. I'm going to start with the counting board. Eleanor, how do you write 7 and 11 in Roman numerals?
So 7 is VII and 11 is XI.
And could you write those in Roman numerals on the wax tablet? Excellent, thank you. And what we're going to do now is we're going to multiply the 7 by each individual digit of the 11. That's each individual Roman numeral that appears in 11. That's the 10 first of all, and then the 1. And we're going to enter the answer to each of those sums on the counting board. And I'm going to start from the left of the number 11. You could actually start from the right, but I always start from the left. I find it slightly easier that way. I'm going to start by thinking about what a 7 itself looks like on the counting board. We don't actually want a 7 on the counting board just yet, but just thinking about what it looks like. A 7 looks like that. Now, the first thing we want is 7 times 10. Eleanor, how do we multiply anything by 10 on the counting board?
You move it over to the left.
You move it over to the left. You move it one place over to the left. That's the whole number, one place over to the left. So that's our 7 times 10 to start with. And now we want 7 times 1, and that's 7 itself. So that's going to be VII. And what number have we got now?
77.
Good, and that's our answer. And is that the correct answer for 7 times 11?
Yes.
Good, so you can check your answer in that case by knowing your times tables. Now, a nifty thing about multiplication is that 7 times 11 is the same thing as 11 times 7. So we could also think of this the other way round. We could think of starting with 11 and multiplying it by each individual digit in the 7. That's first of all 5, and then 1, and then 1 again. Thinking about what 11 looks like on the counting board, 11 looks like this. I don't want an 11 there just yet, but I want 11 times 5. Eleanor, how can I multiply something by 5 on the counting board?
You move it up.
Good. I can multiply a number by 5 by moving it up to this top register. That's going to be slightly challenging for numbers that are already up in the top register, but we'll come back to that later on. You can multiply something like 11 by 5 by just moving it up to that top register. Good, so that's our 11 times 5. I now want 11 times 1, that's 11 itself, and then I want a second lot of 11 times 1, that's 11 itself again, and the answer again is 77. Now let's do a slightly harder one. Let's do 6 times 22. Eleanor, would you like to write 6 and 22 in Roman numerals on there? We found in the Reading Ancient Schoolroom that it's useful to have a written record of the sum that you're doing, because if by the time you finished it, you've forgotten what sum it was, then it's hard to check if you got the answer right. Thank you. Great. So I suggest we think of it as 6 times 22. We're going to start with the 6, and we're going to multiply it by 10, and then 10 again, and then 1, and then 1 again. Thinking about what 6 looks like on the counting board, 6 looks like that. We want to start with 6 times 10, so that's 6 shifted over one place to the left. I now want a second lot of 6 times 10, that's a second lot of LX. I don't really want a second counter in this box for the L's, because I don't really ever want more than one counter in one of these small squares at the top. But before I add that second counter, I can think, well, 2 50s equals 100, so instead of adding 1 there, I can remove that one and add 100 there, and then I can add my X. So that's my 2 lots of 6 times 10. I now need 6 times 1, that's 6 itself, and then another lot of 6 times 1, that's another 6 itself. Again, I don't really want 2 counters up there, but adding a second one would get me to 10 there, and I can add my 1. And the answer there is what, Eleanor?
132.
Good, and that's correct for 6 times 22. Now we can speed that up a bit, if we like, by knowing our times tables. Because if we want to, instead of taking those two tens separately, and so I'm going to multiply 6 by 10, and then 6 times 10 again, I could say I'm going to start by multiplying 6 times 20, and then instead of taking those two ones separately, I could take them together. I could say I'm going to secondly multiply 6 by 2. Let's see how that would work. So first of all, 6 times 20. Well, 6 times 20 is a similar idea to 6 times 2. That's 12, but it's 12 shifted one place to the left, because instead of multiplying by 2, I've multiplied by 20. And 20 is the same idea as 2, but shifted one place to the left, and that means the answer is also going to be shifted one place to the left. So that's my 6 times 20, and then I can add 6 times 2, and that again is 12, so that's going to be a 10 and 2 ones, and the answer again is 132. Let's do that a little bit faster, because it flows a bit better if we go a bit faster. So 6 times 20 is like 12, but it's shifted over, and then 6 times 2 is 12 itself, and that's 132. Now let's do a slightly harder one. Let's do 76 times 32. Eleanor, would you like to write 76 and 32 in Roman numerals? Great, thank you. Now I suggest we take this one nice and slowly again, without trying to speed anything up. We're going to take the 76 and multiply that individually by each individual digit in the 32. Notice that you can always do this, although it's possible to speed things up often, you almost never have to do that, because it's possible to multiply even quite complicated numbers with each other on the counting board or the abacus before you've learnt your times tables, or while you're still learning your times tables. So we're going to take the 76, and I'm going to start by just thinking about what 76 looks like on the counting board. 76 looks like this, but I want to start with 76 times 10. That's 76 shifted over one place to the left. I then want a second lot of 76 times 10, so that's a second lot of DCCLX. Don't really want 2 counters there, but adding a second one will get me to 1,000 there, so that's the DCCL. Adding a second one will get me to C, but adding another C will get me to D there, and then that's the X. And then we want one more lot of DCCLX for the third lot of 76 times 10, that's DCCLX. And then we want 76 itself, and then we're going to have another lot of 76 itself, so that's going to be LXXVI, that's LX, second X will get me to 50 there, VI, and then we want one more lot of LXXVI, that's LXXVI. And what's our answer, Eleanor?
2,432.
Great, and that's correct for 76 times 32. Now there's a slight complication if the two numbers that you're multiplying by each other both contain at least one digit that belongs up here in this upper register, a 5 or a 50 or a 500, for example, a V or an L or a D. And to see why that causes a small complication, let's do 15 times 25. Eleanor, would you like to write 15 and 25 on there? Thank you, and let's do this one on the abacus. So I suggest we start with the 15 and we multiply that by each individual component of 25, so by 10, and then by 10, and then by 5. And I'm going to start by just thinking about what 15 looks like on the abacus. 15 looks like this on the abacus, but I want to start with not 15, but 10 times 15. That's the same idea, but shifted one place over to the left. So that will look like that. I now want a second lot of 15 times 10. That will be a second lot of 150. That's my second 100. And I can add a second 50 if I remove that 50 and add 100. So that's now my 2 lots of 15 times 10. I now need 1 lot of 15 times 5. Now, thinking about what 15 looks like again, 15 is one of those and one of these, and just now Eleanor said that we can multiply a number by 5 on the abacus or on the counting board by shifting that number up to the upper register. That will work for the 10. We can multiply 10 by 5 by shifting it up here and it will become 50, but we can't so easily do that for the 5 because the 5 already belongs in this upper register. So what we're going to do is multiply the 10 of 15 by 5, because we can do that easily, and then what's left is multiplying 5 by 5. And because I can't do it by shifting 5 up to the upper register, I'm going to have to do that bit manually by just knowing what 5 times 5 is. Eleanor, what's 5 times 5?
25.
Great, and that's 2 10s and a 5, and that's my answer. Eleanor, what number is that?
375.
Great, and that's the right answer for 15 times 25. It's a really useful concept on the Roman counting board or the abacus that 5 times 5 is 25. Or more generally, any number that belongs up here in this upper register, if multiplied by 5, equals 2 beads diagonally down to its left plus 1 bead in its original position. Or if you wanted to multiply a number that belongs up here, not by 5, but for example by 50, then that would be, say we wanted again to multiply 500, not by 5, but by 50. Instead of being 2 beads there and 1 there, it would be the same idea, but all shifted over one place to the left. And that's all based on this concept that 5 times 5 is 25. I believe that Romans might have learnt 5 times 5 is 25 quite early on in learning their times tables. I can't actually prove that, however. That brings us to the end of this video. This is who we are. Thank you for watching, and in the next video we will demonstrate division on the counting board and the abacus.